Hello, welcome. This is a screencast where I take the code that I produced for Everybody Codes and go through it to clean stuff up a little bit. This is also my first time really experimenting with OBS and recording a screencast with my face on it, so we'll see how that goes. So anyway, Everybody Codes, if you haven't seen it before or haven't been looking at my other recordings, and unless you're one of maybe a dozen people who have looked at my other recordings, yeah, of course you haven't. So Everybody Codes is a coding problem website strongly inspired by Advent of Code, but with its own little quirks. They only have 20 questions a year. I assume this is the first challenge they've done. I finished them in earlier screencasts. So this is a screencast where I just try to make it so that I can solve all of the problems, or at least as many of the problems as possible, with code that runs in under a second. And for this, I am going to be taking advantage of all of the quirks of the input that I possibly can. As an example of the kind of quirk I might take advantage of, Part 3 of Quest 20. Quest 20 supposedly involved guiding a glider around, and in Part 3 you had been thrown off and away, and you were guiding a glider around a map that extended infinitely long downward just by taking your input and repeating your input again and again and again. So here's the example where you have, given this input, you would be guiding your glider along this path, and the idea was how far can you get with your glider before you hit height 0? Starting at the specific height, how far can you get? And the thing is when I saw the input, that is one nice thing about this compared to Advent of Code, is that when I saw the input, it's really obvious that the right thing to do is to move your glider to the left and then just go down. Just straight down so that you only stay in this column. These pluses, minuses, and hash signs you don't want to smack into. They're bad. Pluses cause you to gain altitude. Minuses cause you to lose 2 altitude. And regular spots, dots, cause you to lose 1 altitude. So obviously what you're going to want to do is to go to left and then go down and just stay in this column as far as you can, and that's going to give you the best distance for your starting altitude. There's really no other choice. Every other plus sign is in a column that only has plus signs, and the other columns are further away from start. So clearly this gives you the best way of getting into one of those plus sign columns and then just writing it. Anyway, that's the kind of example where my program might not work on every possible input out there, but it completely fits the input I was given. So anyway, yeah, that's the kind of optimization I'm going to be looking for. Anyway, so that's what we're going to do. We have here 20 programs, all written in Go, and I want to optimize them so that they all run in under a second. So the most important thing before you start any kind of optimization is to get a good baseline of where you are. So I'm going to see if I'm going to first try to get a collection of just where we are, what is the what are the times that my programs are running at currently. So here we go. Percent. First, make sure that we have that quest built with the latest code. That doesn't look too exciting, but it is in fact. Oh, and as you can see, I don't in fact have executables built yet for quests 19 and 20. But as this goes on, it will do that. I almost wish I had deleted the executables so that I could then rebuild them here and watch you rebuild them. Okay, there we go. So now what we want to do is we want to build up an array of custom objects that will let us record the quest number, the time that it took, and everything like that. Sorry. Yeah. So here I go. I'm going to create my times. Okay, now so $b equals $underscore $a equals measure command ampersand dot backslash ust $b dot exe dot total seconds. So measure command is a built-in PowerShell command that gives us the time something took, and I'm going to pipe this to out default. out default dot total seconds, and then, although actually to see what's going on here, I'm going to measure command out default to total seconds, and then I'm going to create a custom object, ps custom object at n equals $b n equals $b. I'm not sure if I need a comma here or a semicolon or what, but let's try this. T equals $a. Okay. What is missing? Oh. Missing closing brace. Okay, so what do I do here? I have measure command that dot total seconds. Missing closing curly, so open, open, oh. That should not have been an open curly. Okay, so yeah, you can see that part 12 took a little time, and part 15 is the first one that takes really substantial amounts of time. I believe that part 15 takes something on the order of 45 seconds or 90 seconds, so yeah, I'm just going to speed up the video at this point. See you once it's done. There we go. Yeah, no, obviously part 17 takes a while too. Part 19 will take a little bit, but nothing takes the time of part 15. Okay. Now we look at okay, so a lot of these are already well under a second. So we have 15, 13, 12, 7, and 5. Okay, those are the ones that I want to. Those are the ones that I want to. Profile and possibly speed up. I'm going to be following guidance here from the actual go.dev site on how to use their basic profiler. So let's start with let's start with 12. I want to save 15 because 15 is going to require some tricky stuff that'll depend a lot on how it worked. And yeah, let's start with quest 12. Okay, desert shower. Which one was that? Oh, so quest 12 was the shooting of the meteors. Yeah. Okay, so here is quest 12. Yeah, and at the time of quest 12 I was still doing these things mostly by having a large block inside the main. So let's first just running quest 12. Visually, okay, the first two parts are not worth optimizing. The third part definitely is. This is what I expected, but so what do we do for the third part? So for the third part, I first compute every possible trajectory out of every possible tower. I store that in okay, so first thing we could do is that I'm going to need to look up diff lookup here. Okay, I'm going to need to look up diff lookup at call minus height for all of the incoming meteors. But that's it. Now diff lookup is a map from an int to that. So what I could do is choose the change this map to a slice. In Go, slices are just so fast. They're so much faster than maps, especially maps based on complicated structures as keys. Now we don't have that. We just have a map where the key is just an int. But even on ints, so again, let's check out what this speed is. Okay, so it's coming in at 1.3 when I rerun it, but oh, that's a good point. I probably should have run all of the commands multiple times to get a decent time. I found that the first time I run a command, it's always slower, but still 1.3. We're well above a second. It's a decent. So the first thing I'm going to do is I'm going to get the lowest and highest differences of the heights in the input. Now the input for quest 12 part 3 I do okay, perl-nle matched to new lines and do Okay, and then what I want is I want the max and the min of that. Max equals 0. Max equals 0. Min equals I was afraid of that. MX less than $2 question mark. $MN greater than $1 minus $2 question mark. $1 minus $2 $MN and print min $MX Okay, so those are the two extremes of max minus min. So let's say that diff lookup, instead of diff lookup being this map, let's say diff lookup is a array of and it is 4,000 long. Okay. So then actually let's just do -2 to 3,600. So diff key and then if diff key greater than or equal to -2 and diff key less than or equal to 3,600. Is that the highest yet? 3,600. Then we do this. Copy, paste, okay, so actually this is diff key, and we'd use diff key plus, we'd use that difference plus diff offset. And then here, wherever we look into diff key, whenever we look into diff lookup rather, we got to use that offset. Okay. Now, so now we have so we used to have that, 2.28. Okay, so it's kind of going all over the place. Now we'll do go build Quest 12. Uh-oh. Okay, let's try that. Oh, of course that's not going to work. So oh, wait. This is, I don't want diff offset here. Yeah. Because if I'm using this diff key, yeah, so I can bring that back to, these are exactly the numbers that I get out of the, huh. So how does this change anything? Because so what if I have here, okay, so we do that. Okay, so it doesn't seem to actually help us all that much. Okay, so I guess I have to try that profiling page that I started to look at and then quickly abandoned. So we're going to add this flag to the top of our file. And we are going to put that in here right after flag.parse, which we already had. And we are going to build the program, and then quest 12 dash CPU profile equals quest 12 dot prof. Okay, and to keep there's something weird about the way that PowerShell passes the argument through, so we'll just quote part of the argument to keep PowerShell from being weird. Okay, and now go tool ppprof. This will be quest 12. Quest 12. Okay, and now we say top 20. So, right, obviously, main routine is in main.main runtime.memmove. Interesting. And then main.get trajectory. Okay, so I'm kind of surprised that this is that high. So, what does that mean? Yeah. Doesn't really help me much as to where it's spending its time. Runtime.memmove. Well, what if okay, so if that equals nil, what if we pre-allocate stuff? 0, but what if we say that for every spot okay, that's obviously larger than it needs to be. But this is just allocating a lot of memory ahead of time so that we won't have to move it, because this append can involve movement, memory movement. So let's just allocate it so large that it obviously has to take everything, because you look here at this range and yeah. Well, we do seem to have gotten it under 1 second. It's still higher than I would like. So I'm going to run the profiler one more time and see if there's anything possible that we might have missed. Okay, so memmove still is being activated. It's being activated way less. But it's still there. Get trajectory, of course. Not quite sure what to do here with get trajectory, except to I could over allocate at the beginning. Trajectory went down. We still have a lot of calls to memmove. So we're returning this, and we're appending here and here, and even at low power, we should be well in the clear. Because we append enough to go up. We append power things up, and then we have power down plus whatever the power there is, but then we're doing 4 times power plus 2. That should be enough. I mean, honestly, that should be enough. And that's a kind of tight bound, but let's just, because the tower could be at 0, 1, or 2. So that's a decent that's a decent improvement, though. I think we've gotten this. The other thing I can think of is so one thing we could do with the input, we only need enough power to solve the input. So let's what is the maximum of that? Wait, really? Oh, no. So the maximum is of the first. So the first thing is 722, and the second thing is 3702. So okay, so the maximum column out is 7202, but here's the thing: the maximum height is 3702. Now we can only intercept something at most if we are kind of halfway up. So really, this is okay. 1851. Let's try 1853. And yeah. I was just looking here about let's try. That should be enough power. That's really slicing tiny bits off, though, because 2000 to 1853 to 2000, that's not a huge not a huge difference. Yeah, we're still at the 0.8. Okay, it's possible that there is a complete reworking of this. totally different way to look at stuff. Well, one thing I considered is maybe there's even some kind of pseudo-analytical way to look at this. Yeah, but it just seemed so fraught with all of these special cases. What if we hit it on the upswing, if we hit it on the downswing, what powers can we hit it with? And that the easiest thing to do, as far as I could tell, is to go through here till I have this. You can tell I do have some sorting stuff that is commented out. I had that at the time, and I concluded it did not help. How are we doing for time? Okay, so I'm going to declare this optimized. Now, let's format my table again. Okay, 17, 19, and 20. Well, let's, you know what, screw it. I'm going to go for 15. So, here's the thing about 15, Quest 15. Quest 15 was basically a traveling salesman problem, except that what you had to do, you were traveling this, you know what, the input is not great. Let me, the website is not that great for looking at that input. Let me open Quest 15, and then let me go find the actual Quest 15 data. Yeah. So the deal in Quest 15 is you're doing this traveling salesman problem where you've got to find everything from you've got to find everything. You've got to start at the start spot, that one single spot up there, and then you've got to go around collecting every single plant. Now, what might not be obvious is that this map divides itself into 3 vertical segments. One vertical segment is roughly from here to here, and the boundary of the segments are these interesting back and forth vertical lines, of hash marks, because you can't go through the hash marks. So the boundary is right here, and the only way through the boundary is all the way down here, this K piece. So the hint I got from Reddit is that you should be able to divide the problem in thirds by whatever the particular special plant is in your input. And with my input, the special plant is K. It's on both sides. So what I am going to do is I'm going to divide the input into stuff to the left of this K, stuff between the two Ks and stuff to the right of the K. Because in the same column as the K, I don't have any plants. Yeah. I don't have any plants actually in the same column as the K. I just have plants to the left or the right. I mean, any other plants except for the K itself. So, now, so here, I'm doing problem 3, and what I want to make sure is I want to make sure I get the, I want to make sure that I get the left plants with the left. Right, and in these things, yeah, if I have stuff so stuff on this side, yeah, is all the first part of the alphabet, A's and B's and C's and an E. Oh, and there's a D. Yeah. So I have different plant types in the three different sections, and they are only connected by this K. So I'm going to say plant power. So the way I'm going to deal with dividing this problem in thirds, because it's a traveling salesman problem where you've got to start at the start, visit every kind of plant, and go back to the start. So what I'm going to do is I'm going to say that if you're visiting plants on the left, you have to finish all of them before you go back, before you leave that area to the left. And if you're visiting plants on the right, you have to get all of them before you leave that area to the right. Now, the way I'm going to do that, the way I'm going to enforce that, is I have at each plant. So one of the things I do is I for each plant type, I assign each plant type a power of 2, and it goes up. You know, as I discover new plant types, I assign new plant type, okay, new power of 2. Then I get all of the plant locations, and I make this array, and plant loc power is an array parallel to plant locs, and it gives for the plant that is at spot X in plant locs, what is plant spec of the grid map at that spot. So anyway, I can split it into 3 parts by saying that if you have any of the bits of left, if you're at a plant and your power is in the left number, then you're on the left. Plant and your plant power is in the right number, you're on the right. Otherwise, you're in the middle. So plant power left equals 0. Right. Okay, and you know what, I'm going to do this after I've already parsed the thing. Okay, so plant power left, plant power right. For IDX, plant range plant lokes. Okay, so I need the 2K values. So K power equals plant spec bracket K. K power calls for yeah, okay, and then I go through two of these routines. If plant loc power IDX equals K power K power calls dot append plant loc dot column, which is Y. And then if lang K power calls is not 2 log dot fatal and then here we have if plant loc dot y less than, okay, now here this K, there really is nothing above it, yeah, so I can just use strict less than or greater than. Less than K power calls 0 if plant loc dot y greater than K power calls 1 and if this is true, then plant power left or equals plant loc power X. Oh, whoops, these need to be uint 64s. Plant power loc, okay. So, now that I have those two spots, when I actually do this function, okay, that also, so if we have an ending that is not in left and our goal contains some of left but not all of left, so if goal and plant power left is not equal to 0. And goal and plant power left not equal to plant power left. If that is true, then we have to check if plant loc power ending and plant power left is equal to 0, then this is no good, okay? Because this is saying that you are doing a partial of the left and you are ending somewhere not on the left, and that is not allowed. And so then we just say that. And then we all do the same thing again for right. Okay. Copy, paste, paste, paste. Okay, I think this should break the calculation up such that it doesn't go and get too terribly recursive. With stuff we can't do, and it should break it into 3 parts. Now, before I go and do that, before I go and change that, let us remind us of the answer here. It should be 1562. So, go build Quest 15. Quest 15. Well, that's a lot faster. We're still not quite there, I don't think. Okay, so we went from 85 seconds to 2.9. Yeah. So 85 seconds to 2.9. Well, that's pretty good. Let's try it again. Let's try again the 85 seconds to 2.9. Man, I really thought this would be much better than just 2.9 seconds, but PowerShell is weird with quotes. Oh. Go build Quest 15. Yep. Okay. Main.doProblem3.func1. Runtime map access. Okay, so we actually spend a lot of time in accessing maps. Even in the other parts. Oh, okay, so let me look at this. Do problem 3. I'm pretty sure func1 is going to be this best dist function. Okay, so anyway, I can what if I avoid the recursion when I can? I do pre-goal and butt end, except that if butt end is equal to ending, we continue. Or if butt end, or if butt end is that and the pre-goal is 0, we do that. Or and we could do these other two complicated conditions here. We might as well. Yeah, we might as well. Okay. So each of these long conditions, requires 3 things to be true. Plant power left and plant power left. Copy. Paste. Okay, now ending is butt end. Well, plant. So butt end. And this will be pre-goal. Now, okay, so pre-goal. So we're going towards a goal, and we're already guaranteed that the goal doesn't. Okay, if that, or same thing but with right. Okay. Now, I believe I can just do that. Yeah, because we still do end up using a lot of hash access here for this cache. So by the way, we're still getting 1560. Yeah, we were still getting the right answer. Okay. Yeah, okay. So we're still around, right, before I said 2.9, and now we are sometimes above, sometimes below. Yeah, so that didn't actually help us. That didn't actually help us at all. So let's undo that. So okay, well, I'm going to stop because I have been recording here for over an hour. I intended to do only an hour. I may do another one of these because I want to get everything under a second, or decide that I just can't. And I think we've done good progress, although we've only attacked 2 problems. One of them was the big behemoth of problem 15, and that is now down to about 3 seconds. So that definitely means that I have succeeded in getting the whole of this down to, well, I mean, obviously it's not down to under 20 seconds yet. Not down to under 1 second on average yet because of those 2. But this does mean, I think, because I haven't even tried to optimize 19 and 20, does mean I think that the optimization, or the idea that I would have, even if I can't get everything under a second, I can certainly average under a second. That's easily within reach. That's easily within reach, having cut this way down. So I guess you'll know if I do this, because future you will be watching after I've already uploaded the recording, and you can just look at the playlist that'll show up and cover up my face probably about now. Thank you for watching. And let's hope I remember how to edit this so you don't watch me fumbling around looking for the stop recording button.